Hello everyone. Today we are back with one more installment of the network internals video, and here not only the basic networking, but we are also going to cover some part of it towards the real life use cases, like for example how Zoom, Microsoft Teams, and the Google Meet, these things are using UDP. Okay, so what we are going to do is we are going to talk about UDP. We are going to learn about its internals, and we are going to also talk about its vast array of use cases. So just to start with, like any popular video audio conferencing softwares, they are using UDP behind the scene. So there is a very big difference between a TCP and the UDP. TCP is the transmission control protocol, and UDP is user datagram protocol. So not only on the video conferencing application, suppose anywhere where we do not need the guarantee of the packets. For example, when we are talking about the guaranteed delivery of the packets, if we are taking a simple queue of requests like this, reliable and in order traffic is a must. Suppose you are as a user commenting something on the Facebook. Just say your comment is broken down into IP packets. Like here, as you can see, like this is probably one of the traffic that is being going on, and there will be like three packets: packet one, packet two, and packet three, which your comments is getting broken down into. Now, just imagine if your comment IP packets does not reach in order. Suppose when it reach at the server end, how it is like the packet 3 comes at first, then packet 1 comes, and then packet 2. Then how odd your comment would look like. Like I'm just taking a very simplified example just to make you understand, but probably you get the idea that in case the transmission that is happening is not maintaining the order, there will be a very big problem that will be there. Okay, so TCP is the thing that make the delivery reliable. It even retransmit the lost packet. For example, for some reason, suppose after packet 1 the packet 2 hasn't reached, the packet 3 has reached. So what it will do is in the communication it has the ability to resend the packet to. Okay, we are going to discuss TCP in our next video, so I am just saving those nitty gritty for now. But just understand this thing: when we need all the data in correct order and without any error, like when there is no room for error in the terms of the transmission, so there we are going to use TCP. Okay, so this is the part where we are going to use TCP. And but there are cases when this can be a lot of overkill. So there comes UDP. Okay, so again, before coming into the details of the UDP, let's understand it via use case. And just to make sure that you understand that, can go to your task manager, then go to the performance tab, and then go to the resource monitor. Under the resource monitor listening port, you will see that there are a number of uh, there are there are a number of port which are listening to the UDP traffic. So UDP is everywhere, and what exactly the use case, we will gradually unfold it now. Okay, so suppose you are doing a video call with your friends. Now let's figure out under TCP how it did look like. So again, this is a completely hypothetical situation just to make you understand the problem that we might run into with TCP. Uh, we are doing this simulation or the exercise. Okay, so now so at first what would happen is like suppose I have talked something, so I'll be sending a frame. So frame 1 is being sent there. Okay, and then from there the frame 2 will also be sent, and also after that what I'm doing is I'm sending the frame 3 as well. Okay, so whatever I have talked, probably like a 1 minute monologue or something, it gets into this three packets. Okay, into three frames we can say for the time being. Now for some reason the user's connections get jittery in between. Okay, and like then what would happen is this particular frame, this is not frame 2, this will be frame 3. Yeah, so this frame 3 will get dropped from here. Okay, and also after that I'm also sending some further frames as well. So like let's mark them as this will be frame 4, this will be frame 5. Okay, so only this is the one that didn't reach to the internet also. So now what would happen is after the whole this whole message, which is divided into frames, would try to get delivered to your friend's end right now. So now it is on the internet. So what would happen is like the frame 1 and the frame 2 definitely will get delivered, and then at this level, suppose I'm taking it. Okay, at the frame 1 and the frame 2 is getting delivered, and then a wait will start. What would happen is it would start waiting for the frame 3, because in my whole message or in my segment I have already mentioned that man there will be 5 frames. So it is seeing that the next frame is not coming in. Okay, so here what would happen is here waiting for frame 3 would happen, and although the frame 4 and the frame 5 have reached into the machine, but they will have to wait. Okay, so the bottom line is at this stage these guys have to wait. Okay, let me take it here. Sorry for the trouble guys, like this is just little problematic at times. Anyway, so the frame 4 and the frame 5, what would happen over here is this is basically waiting. Okay, and like again it will say that I haven't received frame 3, so it will ask the frame 3 to retransmit. So again the retransmission of the frame 3 would happen in this level. There is again, this is the interesting thing that would happen, that is the retransmission of frame 3. Okay, so now a retransmission of frame 3 happens at this level, and once that retransmission happens, and then this from the waiting state, what would happen is then they would get delivered. Okay, so there is a particular term for also it, like when this buffering or this waiting is going on, we call it head of the line blocking. Okay, we call it head of the line blocking, or very famously known as HOL blocking. Just remember this term, this is a very important one, like in terms of the networking flows, and just to avoid that there are many further invention also have happened. But now probably you understand the problem. Okay, that there are multiple frames are going on, and this 2 frames are delivered, the third is being dropped. Until the third is being retransmitted, the this 4 or 5 will not be going. Okay, so I think this is pretty much clear. So now let's take the example in terms of the timing, so that the understanding solidifies in the mind, and we will be more closer to what happens into the real life. Okay, so suppose I have started sending it. So at the 0 millisecond I am saying something like hello. Okay, and hello gets split into 5 packets, so A1 to A5. Okay, now on the 100 milliseconds, what we see is due to the due to the problem of the network glitch, um, there is a network glitch. Due to the problem of the network glitch, A3 gets dropped. Okay, and the receiver gets A1 and A2. However, after that it keep on waiting. And although, like suppose this happens around 120 milliseconds, okay, and then at the 130th millisecond, although in that receiver machine A4 and A5 arrives, but the application, the TCP connection realizes that the A3 is missing. Okay, so at this level, TCP realizes A3 is missing. Now it will wait indefinitely, and then until the A3 again gets delivered, it will, like, it will not be coming into the machine. Okay, but what exactly happens in the case of UDP is, so although the UDP realizes that something is missing, okay, the application realizes that this particular data is not coming, okay, but it won't wait. So this is actually a wrong term, that UDP can't really realize that whether something is missing or not. The application have to have keep track on that. So in UDP, although A3 is missing, there won't be any wait. Okay, so there will be no wait, and what would happen is, after no wait, there is something called PLC comes in play. That is known as PLC, or Packet Loss Concealment, I think. Yeah, it guesses the missing audio based on the surrounding data. Okay, and they also have something called a jitter buffer that is implemented on the application end. It smooth out the timing variant, and then the thing how it would look like is hello, something like this. Okay, if the second L is not going, what I'm thinking is maybe the A3, like A3 was having L, so although it is missing, so it would little bit sound like this. Okay, hello. Okay, with a little pause. So whenever you are listening to your, like, Teams video call or Google Meet, whenever you see this kind of jitteriness, just understand this PLC is being coming into the picture at that point of time. And this is a very important aspect of Zoom, Microsoft Teams, or Google Meet. Now let's formalize uh, what would what would exactly happen in this case. Okay, uh, in the way we have been doing it for the retransmissions for the TCP, let's try to just formalize what would happen for the UDP. Okay, so now that I send my first frame, the frame 1 will go as it is, and then what would happen is, like just a second. So I just drew all the frames and lost frame 3 just to save some time. So as you can see, like, all of this frame 1 to frame 5, they are being delivered to the internet, but the frame 3, due to the jittery connection, it just got dropped. So now please understand, this is happening in UDP and in WebRTC. So WebRTC is the tech behind the most video calls. Okay, so you can read more about it, but WebRTC, behind the scene, it uses UDP. So how it is happening is, it is happening in UDP, and with that there is one more important concept that happen in the video calls, which is being known as FEC, or forward error correction. So in all the packets that UDP plus FEC will be there. So what exactly FEC is? It is a very interesting concept. In FEC, it is a technique that sends extra redundant data along with the original data, so the receiver can reconstruct the lost packets without asking for the retransmission. So FEC is the magic basically. FEC make sure that you can reconstruct the data. Okay, so the forward error correction, or the FEC, is the secret sauce onto that. So what exactly happens over there is, the audio and video packets are being sent on the UDP. it is the fast and without any guarantees. So it doesn't need any kind of acknowledgement or a complete connection pipelines or something. Internet drops, so some packets, suppose 1%, 2%, 5% loss are happening over here. So that audio snippet is gone or that video snippet is gone for sure. Like this frame 3 was that audio or the video snippet, it is gone. So now what happens at this end, let's try to understand. Okay, so now that we have this many number of frames, okay, so this is getting delivered with the FEC, this is also getting delivered, and frame 3 is of course not there, so it detects that it is missing, and what it does is then the PLC and the FEC, both of this thing comes together. Okay, so FEC, as we have been discussing, it is the forward error connection, and PLC is the packet loss concealment. So with both of this thing coming together like FEC plus PLC, it kind of try to guess or interpolate what exactly is the audio from 2 and 4. Like if I have 2 and if I have 4 already, then what exactly is the audio among them? So look, all of them already actually arrives there. For example, if I see the frame 4, they also arrives. But just before playing, it is the responsibility of the application. What it does is using this FEC plus PLC, it guess the audio or the video. Okay, it guess the audio, or I can just take a short form. It guesses the AV, and like it just plays it smoothly. There are some other algorithms are in play as well. So you can see, although there is a minor glitch, there is no delay in conversation, and it stays completely in sync, and it almost, that is why it almost feels like a real time. So whenever you are again calling with someone over the internet, maybe in the Teams, in the Google chat, then or in the Google Meet, then if any point of time, if some jittery is happening, that means at that point of time the FEC and the PLC is trying to guess the audio and the video which is being there. Okay, so I think now we understand the very basic difference of the TCP and the UDP. So if I ask you, probably you'll be able to say it in this way, that the every byte must arrive, and whereas what UDP or the user datagram protocol does is, like, it makes sure like on time delivery, and it non-complete, of course, like it doesn't guarantee complete. And what are the use cases? For example, whenever we are doing some kind of a video stream in a real time, or some kind of a gaming if we are doing, so in all those cases UDP shines. Okay, so now in case you have seen the first video, like we have touched upon some very basic concepts of TCP, and in TCP what happens is, in TCP, so in TCP there are so many things comes into play, like there is like window size, there is sequence, there's like which is making sure that everything is coming in order. Then there is ACK, and then there is things like buffering state. Okay, so all those things comes in to that, and each of these takes up some memory in the RAM or the CPU overhead to the server. So what happens in case of the UDP is, UDP doesn't care about all these things, anything like those. So in this case, it doesn't take that much of RAM memory. So now another statement probably I can make alongside this. This is a memory intensive operation, and this is a light memory operation. memory light, I can say. Okay. Now, probably one of the main issue if you are looking at closely, one of the main issue that you will be able to identify is that uh, right now my UDP connections are being listening to this port, and again there is no guarantee or there is no connection establishment, the public key private key, those exchanges that are happening, which happens for the TCP, right? So that makes UDP vulnerable. So that is um, one of the problem with the UDP is UDP is very vulnerable. So if you just see, there are like historically all the attacks or all the cybersecurity major incident that has happened, uh, that all happened because of the, like, not all, like most of them happens because of the UDP vulnerability. Like for example, uh, here as anybody can send their datagram or the segments to the UDP part, the server must process it, and server is again responding it. So if somebody is able to reach to my UDP port, so I will just write it there. If somebody is able to reach my UDP port, server has to process it. So the moment server processing it, and if there is some kind of a DDoS attack or something is happening, that means the server or the OS or the server or the host OS, okay, server is nothing but a host system, right? So server or the host OS will become very busy, and all of the memory will be taken out. So just for your interest, you can see like in 2016 there was a very famous incident called Mirai botnet attack. Okay, so you can just look up to it. So what exactly happened is, like, there is a major DNS provider based in US that manage the domain name of many popular things like Twitter, Reddit, Netflix, and whatnot. Now what it did was, like, it found a vulnerable UTP port of that particular DNS provider, and the Mirai botnet keep on blocking it by sending DDoS attack. Now this kind of things, how do we stop this kind of things? Like what major cybersecurity, like in detail, if you have to see, like, that is what the major cybersecurity domain is there. But just understand one thing: there are few things like any cast IP that is being used, and currently as if we are using like CDNs like Cloudflare or Akamai, they already do take care of this kind of things. Okay, and even if, like, for example, by default Azure traffic managers, or in your AWS infrastructure, your ALB, the AWS gateway, all these things make sure that even if a UDP traffic comes, there is less chance of DDoS attack. So all these vulnerabilities are being checked. But again, the outcome, the takeaway that I want you to take is UDP being completely open to the port, and because anybody can keep on sending the traffic, there is no guarantee or nothing is happening. Like as you can see, even if the frame 3 hasn't reached, all of them are delivered. So it makes UDP vulnerable in its with all of its advantages or the speediness as well. So as an application programmer, let's conclude this video by understanding how it is actually being implemented into a real life in our code bases. Okay, so at first, probably the one of the most key things that should be our takeaway is, in UDP there is no handshake, and of course there is no formal connection establishment, and there is no connection tear down also. Oh, my spelling. Yeah, so there is no con tear down also. Okay, so there is no handshake is happening, no formal connection establishment happening, and no connection tear down. So how all the datas are being sent between the host machines that is being sent as independent packets. So these are the key terms we have to remember before going into before going into the code and trying to understand it. Okay, so um, there is nothing like a UDP connection. Just understand this thing is in a very subtle manner, that when two machines are exchanging UDP traffic. Okay, suppose there is a AV sort of app or video conferencing app, okay, which is exchanging the traffic. So there is no UDP connection, direct UDP connection is being made from one machine to another machine. Rather, what they are going on is, if you see clearly, it just sends the independent packet. So with this idea, now let's come to our code. Okay, so here the code that I have tried to show you is, this is a very basic code. What it is doing is, it is a sound app, okay, like where we are, or rather a simple walkie-talkie sort of a app, you can say, based on our like sound recording. There is a library for that in .NET called NAudioWave. So what we are doing is, we are using the NAudioWave, and using that one we are just sending the uh, we are just sending it over the UDP. So how are we sending? So you can see there is a event pattern that we have written over there. So whenever there is a, like after starting the record, whenever there is some sort of bytes available to send across, what we are doing is, using our UDP client, we are just sending it across. So this is how we have created our UDP client over here. It is actually coming from the system.net or the system.net.sockets. So from there we are just doing a send, and where are we sending? If you see, we are having a receiver endpoint. Okay, so these are the primary things we should be understanding. There is a receiver endpoint, and this receiver endpoint is here also. Okay, and then what we are doing, we are just sending the buffers and the byte recorded to this ones. Okay, so all the bytes that got recorded, we are just sending over our UDP. And look, there is no connection establishment is happening. Like, I am not passing anything that which internally make sure that the connection or the some kind of a TLS level establishment is there. So there is no handshaking is there, no formal connection establishment, or no connection tear down, only independent packet. So the same code, when we wrote like TCP client.send, behind the scene there is been a handshake and a formal connection and a uh, TLS agreement that has been there. So that is the very basic difference between the UDP and the TCP. Now, how it is being received from the other end. So now you see that this is the IP of the receiver and I am just sending it. So over here, this is the receiver's code. Okay. So in the receiver's code, you see, so what I'm saying is, anybody, like I'll be like in my local endpoint, from any of the IP address, if anybody is sending something at 9090, here probably we should note this part, here is also it is 9090, and in the listening port also, or at the receiver end also, it is 9090. So what I'm saying is, when you are sending it across to this 9090 port, I am going to receive it. So this is the, again, primary code that we should be looking at, that I'm going to receive it, and whatever the web provider, like this is kind of a buffer, that buffer object that we are creating, I'm going to add it to the buffer object, and then I could use it for my streaming. Okay, so all the streaming information I am not showing it here, but just understand one thing, the here I'm mentioning while sending it that the receiver endpoint is 9090, and while receiving it I'm telling that anything in my local 9090, if you are getting, you please receive and then add it into my buffer sample. So probably now you understand this fact that TCP is just an independent packet exchange. So just to reiterate the fact how these two hosts are working together. So if you see, here is UDP. It is telling that while sending it, it is telling that send to the, this is, suppose the IP is this 127.0.0.1, send to this particular IP. Suppose I am making this statement, send to this particular IP. Okay, and in this particular IP, like in the port 9090, you sent. So this particular UDP port is already listening to 9090. Oh, okay, this is already listening to 9090. So it will come here, and then the host will be able to process as per the application code. Okay, so this is pretty much it. So just if we just see example voice chat app, or like any kind of conferencing app, walkie talkie sort of a thing, everything works like this. Okay, and also you might be wondering uh, how exactly the like simultaneous send and receive can do. So in C sharp, like if I just have to tell you, in any other language it would be quite similar. In C sharp we can do something like this. So I will just take you through the code. So I create a infinite while true loop for that, unless somebody cancel it with a cancellation token. I will keep on listening, and here you can see with a while true and the task casing, that is means like with a background process I am just listening to it, and meanwhile another process I can start there. Whenever I am getting a audio chunk, what I will keep on doing is I will keep on doing a send async with a task delay of 20 milliseconds. So in every 10 or 20 milliseconds, whatever the audio chunk that is being generated in the client end, that will be sent, and always, like as you can see, the receive async is as a while true, it will be running. So if we just implement this thing in our process, you can see like receiving and sending both are being taken care here. So that's the primary idea, guys. Like for the UDP, these are the key essentials that as an application developer that we should be knowing. Like just to just to reiterate it, like that TCP is a connectionless protocol. It works in any kind of gaming, or it powers all the applications that are using this audio video conferencing sort of a thing. And also, like how we can just write a simple walkie talkie sort of application, we just explored the code of that. And also, in case we have to write a simultaneous send and receive, how we can do it very easily using our UDP client, we have just explored that as well. So that's the video, guys. I hope that the concepts around the UDP was clear. In the next video, I'll be back with the details of the TCP connection. Stay awesome. Bye.